Hi Biology, Mr. Wagner here. Today we're going to be talking about pedigree charts. Pedigree charts can also sometimes be called a family tree. Let's go from here and see what we have. We can move our slide. There we go. What is a pedigree chart? It's a record of family marriages and births through several generations. It's used to study the transmission of hereditary conditions. Useful when there are large families and there is a good family record over several generations. Studying human genetics, pedigree charts offer an ethical way to study human genetics. That way we don't have to do experiments with people, making them reproduce with others or not reproduce or any of those kind of things. Today, genetic engineering has new tools to offer doctors studying and treating genetic diseases. And usually a genetic counselor will still use pedigree charts to help determine the distribution and the probability of a disease in an affected family. So maybe if your father or mother have a certain disease and it's very often passed down and you don't have it, maybe when you get married, you want to have a test run to see whether or not if your husband has it, maybe if there's a probability that your child may have that hereditary disease that your parents had, something like that. Okay, here's how you use a pedigree chart and the symbols that are there. Males are blockheads. It's an easy way to remember that. A normal male is a unfilled in square, a blockhead. And if you're filled in, colored in, or black, then or usually blue, whatever color they fill you in with, that means you're affected with the trait or the disease. Females are circles, normal female, affected female, and this represents a marriage, a man and a woman coming together. Now, I understand that not every case of a child being born always comes from a marriage. I get that, but this is what we're talking about is they've had a union and they're having children. So in this example to our right, a marriage with 5 children, 2 daughters and 3 sons. The eldest always starts on the left. So the oldest is a daughter and then the son, and then the middle son looks like he has the disease, and then another son, and then finally a daughter on the end. Always start eldest child on the left, going over to the right. So here's the organization of a pedigree chart. This is kind of what something would look like. Are showing 20 different individuals. Squares, of course, are men. Circles are women. And here's how we're going to do it also. They do it by generation. Roman numerals off to the left. 1, 2, 3, 4. 1, the first generation is parents. Second generation is kids. Third generation is grandkids. Fourth generation would be great-grandkids. So you always start with the husband and wife, and then their kids, grandkids, and great-grandkids. Roman numerals are what's used to identify them. Yep. Individuals in each generation are identified by Arabic numbers listed on the left. So again, generation 1, 2, 3, 4. And therefore, then you list them over. Oftentimes, numbers are given. So in generation 1, individual 1 would be the male. Individual 2 would be the female. There's only 2 in generation 1. In generation 3, the 2, 3 would be the affected female, the female that's circled in or colored in black. In generation 4, that would be the second individual, that's also a female. And then in generation 4, the third individual, that would be the male that's also affected. Some pedigree terms to know. Autosomal. Autosomal recessive. This simply means it's non-sex chromosomes. It's a not sex-related issue. Autosomal simply means not sex-related. Recessive means lowercase letter carries the disease. Autosomal dominant. Again, autosomal, non-sex chromosome. And dominant simply means that the capital letter carries the disease or the effect, whatever it might be. Some pedigree terms to know. X-linked recessive. That means it's on the, it's recessive means lowercase letter on the X trait of the sex link of this X chromosome. X-linked dominant means that it's a capital letter. And then very rare, but there are some Y-linked, which involves an allele on the Y chromosome. A Y chromosome, very rare. We're not going to talk too much about that today. All right, so here's an example, someone who's a tongue roller. A tongue roller, well, right now we don't know whether or not it's a capital R or a lowercase r. We're going to pick R for roller, but which one of these is it going to be? Is it going to be a capital R that carries the trait, or is it lowercase r that carries the trait? We can figure some things out here. Here's what we do. If we have 2 affected individuals that give rise to an unaffected child, then the trait is dominant. So if I got 2 people that have it, and the child doesn't, it has to be a capital letter, it has to be dominant. So roller allele is dominant. Capital R means that you're affected, or you have this ability to roll your tongue. Non-rollers are recessive. So based upon that, I know right away that those two cannot be. They cannot be lower, lower, right? And the reason is they can't be lower, lower because their children would have to all be lower, lower. Because the only letters the dad could give is a lowercase, only letter a mom could give is a lowercase. And so both children would have to be lower, lower, and that's not what we have. We have one affected and the female not affected. So that is not correct. So let's go back and redo it. It has to be capital lower. And it can't be capital R, capital R. Why not? Because daughter in the 1, 2, third generation, 1, 2, 3, 4, 5, individual 5, it's listed there as a 4. But it has to be capital R, lower R for those two individuals, the mom, the dad, and the mom, because they have a daughter that is lower, lower, not affected. Okay? So it has to be that. So now I can go through and I can fill in, as we did, lowercase r for everything that's clear or not affected. So the female, the mom at the top is lower R, lower R. In the second generation, the second individual is lower R, lower R. In the third generation, the first individual, the man, is lower R, lower R. We can fill all those in. Okay? Now that we fill, so all non-rollers, sorry, my apologies, all non-rollers have to be genotype lowercase r, lowercase r. And that's what we just filled in with all those. There they are. They're all filled in. Lowercase, lowercase. Yep. Now, we can go back. If one of the parents is a roller and the other is a non-roller, all the children must be heterozygous. They must be heterozygous. If a parent has a non-roller child, the parent must be heterozygous. So let's take a look. Here's an example. So the very top individual, the male at the top in the first generation, he has to be a capital R because he's a roller. So capital R again means it's anything with black in it has to have a capital R. But he also has to have a lowercase r, and the reason is the daughter in the next second generation, you can see the daughter there, the first daughter, the oldest daughter, she is a non-roller. So she got a lowercase r from mom. She had to have gotten the lowercase r from dad. So dad has to be capital R, lowercase r. There's another example we can figure that also. Here's another one. The dad, we don't know, this is a dad that married into the daughter, but we know he has to have a lowercase r. He's got a capital R because he can roll the tongue, but he has to have a lowercase r because he has a son who has lower r, lower r. And for that son, the lower r, one of them came from mom, the other one had to have come from dad. So we can figure out exactly what the genotype of that dad is by looking and filling out some facts there. Now this one over here, we can't tell over here. This individual, it looks like the woman in the second generation. Underneath it, there's a Roman numeral 2. I don't like it. They should use numbers. Roman numerals should only be for the generations. But you can see where the green arrow is pointing. She married the son who has a capital R, lower R. But since she's married, all we know is that she's got one capital R somewhere because she's darkened and colored in. So she could be capital R, lower R, or she could be capital R, capital R. Same for the child, individual number 3 in the third generation, Roman numeral 3 that the other green arrow points to. Both parents are capital lower, so it's possible that child could either be capital capital or could be capital lower. And then finally, the last individual in the third generation, the male who married the female that had the lower R, lower R. I think it's female number 4, it says there. We have no clue what that is, other than he must have one capital R. Why does he have at least one capital R? We know that because he's a roller. In order to be a roller or tongue roller, you have to have at least one capital R. So there we can figure out and fill in all the traits of all the individuals based upon this little puzzle. Let's try another one. Tongue rolling. It says, unfortunately, people can learn to roll their tongues also. But this is a genetic trait as well. Let's look at this one. Here's a genetic trait for albinism. It is not sex-linked, even though you see the letters X and Y. That's a poor choice. They just went L, P, Q, and then they did X, Y to label individuals. So it looks like we got 4 generations, okay? And let's find out what albinism is. It's a recessive condition, so that means a lowercase letter. If 2 unaffected individuals give rise to an affected child, the allele for the affected condition is recessive. Recessive means lowercase. The affected parents are carriers. They have a capital, which means they don't have the condition, and they have a lowercase, which means they carry the condition. Yeah. Thus, recessive conditions can skip generations. Inbreeding causes the chance of carriers producing an unaffected child. Okay, let's take a look at what we got here. So we know that if you have albinism, it's a recessive, you have to have lower A, lower A. So the first thing we do is go throughout our whole chart and we fill in everything that's colored in with lower a, lower a. Has to be that way. Has to be that way. Now we're going to look down here in the fourth generation. In the fourth generation, some of the children ended up being lower a, lower a. So that red arrow is pointing to individuals P and Q. They're in the third generation. And the female wife P and the male husband Q, they do not have it. So if they do not have it, they have a capital letter A. Capital letter A means I don't have the condition. But the second letter for those individuals must be lowercase. Why? It has to be lowercase because some of their children got one lowercase from mom, one lowercase from dad. Because some of the children ended up being lower A, one of those lower A's had to come from mom, so that's her second letter. And the other lowercase had to come from dad, Q, that's dad's second letter also. Same thing over in X and Y. We know that if neither one of them have the condition, they both have a capital letter. Capital letter would mean I do not have albinism. But they have a child in the fourth generation, the very last male, who is affected. Therefore, one of the lowercase letters had to come from dad. One of the lowercase letters had to come from mom. So we can fill in mom and dad as capital A, lower a, capital A, lower a. Make sense? All right. Good, good. Let's do this last one. Brachydactyly. Brachydactyly is a disease in which you have really shortened fingers and toes. Your fingers and toes are too short. So let's see if we can figure some of this out. Right now, we do not know if the capital letter carries it or if the lowercase letter carries it. So let's see if we can do some investigation. All right. So it looks like, again, we've got a case here with our letters. Let's see if we got this filled in or not. Sorry, my bad. Go back. So here we have a case in which I have two people that are affected in the third generation, individuals number 3 and 4. 3 is the female, 4 is the male, and they have a child that is not affected. So an only way that can happen is if they have a capital lower, and then the child has lower, lower. Again, if the disease was carried by lower, lower, then they would both, mom would be lower, lower, dad would be lower, lower, and both the children would only be lower, 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 lower. But we have one child affected, one child not. Therefore, I know for a fact it has to be this way. Individual 4 could either be capital A, one from mom, one from dad, or could be capital A, lower a. But I know individual number 2 in the fourth generation, that male, has to have a capital A because they don't have the disease. Has to have a capital A, has to have a capital A because they do have the disease. My mistake. They do have the disease. Okay? So let's see if we can go back and fill in some of the others now. Okay? I can fill in all the lowercase, all the clear ones, because I know all of those now are lower a, lower a. So anything that's clear is going to be lower a, lower a. I fill them all in. Look at that. And now I can go back and I can figure out what the other individuals must be based upon the fact that I've filled all these in. Okay? Once I figure out my A, lower, lower means that they're not affected, I go